All right, ladies and gentlemen, we're going to continue solving systems of linear equations. This time we're going to talk about the elimination method. Okay. Now, the elimination method can also be called the addition method, subtraction method. The most common name is the elimination method. So again, like I said, first paragraph says that another method that can be used to solve systems is the addition or elimination method. These two terms are going to be interchangeable. In order to do the elimination method, you're going to have to multiply both equations by numbers that will allow you to combine the two equations and eliminate one of the variables. Probably going, what do you mean we're going to combine them? We've kind of been combining them by substituting at times. This one's going to be completely different. Okay? You might see the similarities between them, but you're going to see major differences between the two. So again, we're going to be manipulating at least one of the equations to find a common variable with the same coefficient that are opposites of each other and then add them together. You might be sitting there going, what are you talking about? But that's okay. Bear with me. Let's look at the next slide. Let's look at an example. It'll make more sense once we go through this. So right now it says solve using the elimination method. I'm given the equation 4x minus 5y equals 28 and 2x plus 3y equals 47. So the first thing you're going to do is you're going to look at these two equations. Remember, you're trying to get rid of something, okay, by adding the two equations together. So what you should be doing is looking at the two equations and figuring out which variable you want to get rid of so you can solve for the other one. Well, I'm looking at this and I'm thinking, okay, I'm going to choose a variable that I can manipulate in one of the equations so that I can easily get rid of it. So here I have a 4x and a 2x. And I have a negative 5y and a positive 3y. I'm going to do the least amount of work if I try to get rid of my x's. I have 4x and 2x. I can turn this 2x into a negative 4x, which would cancel these two out. So I'm going to choose my variable as x. I chose x because I can change 2x into negative 4x just by multiplying by negative 2. If you're sitting there confused as to why we're doing that, don't worry. Once you see the next few steps, this should hopefully make sense. So we're going to manipulate the equation, the second equation, by distributing a negative 2 into each term in the entire equation. So we're going to leave the first equation alone. We're not going to touch it because, again, we're going to turn 2x into the opposite of 4x. So here we have our original equation, 2x plus 3y equals 47. Like I said, I'm going to multiply negative 2 by every single term, so we're going to distribute it. Negative 2 times 2x gives me negative 4x. This plus 3y times negative 2 is going to give me a negative 6y. And then 47 times negative 2 is going to give me negative 94. So my new equation now becomes negative 4x minus 6y equals negative 94. Okay, again, we distributed the negative 2 into the original equation, and we got our new equation. Okay, so now we can combine our two equations to eliminate my x's. So remember, our first equation was 4x minus 5y equals 28, and our second equation was negative 4x minus 6y equals negative 94 after we distributed that negative 2. Okay, we manipulated the second equation so that we can get the opposite of 4x. So now, very important, you need to make sure that all of your terms are aligned. So you know how when we add and subtract decimals, we have to make sure that my decimal points are aligned? Same idea. Your x's have to be aligned, your y's have to be aligned, your equal signs also have to be aligned, and then your numerical terms without any variables also have to be aligned. Okay? So everything has to be aligned. Do they have to necessarily be in the order of x, y equals number? No. I could have had it as y, x equals number. I could have had it as number x equals y. I could have had it in various different orders, but both of the equations have to be in the same order of the terms, okay? So that when you stack them like this, you can easily add your terms, okay? So in this case now, 4x plus negative 4x gives me 0. Negative 5y plus negative 6y gives me negative 11y. And 28 plus negative 94 gives me negative 66. Okay, so now, notice, the x's are gone. This makes my life super, super simple. I have a negative 11y equals negative 66. Everybody should be able to solve this. To do this, we're going to divide both sides by negative 11, and we get y equals 6. Okay, we now have y equals 6. So we know that one of our variables, which is y, is equal to 6. Now the process for solving for x is the same thing we did in substitution. We're just going to plug in y equals 6 into one of our equations. So now I can solve for x, right? In order to solve for x, I need to plug y equals 6 into one of my equations. I'm going to pick the first equation, 4x minus 5y equals 28. I can substitute 6 in for y, just like I did here. Here was the y, I replaced it with a 6. So now it says 4x minus 5 times 6 equals 28. And we know that 5 times 6 is 30. 4x minus 30 equals 28. To solve this, what do I have to do? Good, I have to add 30 to both sides. So now I've got 4x equals 58 because 28 plus 30 equals 58. If I divide both sides by 4, 4x divided by 4 gives me x. 58 divided by 4 gives me 14.5. So now we think that the answer is 14.5, comma 6. Remember, x always goes before y. I don't care if you solve for y first. Your x is always going to be first in your coordinate, and then y. And this is how we're going to be writing our answers. Now we have to check this, okay? We're going to check this to make sure we didn't screw up any of our math, any of our computations, by plugging it back in, okay? So remember, x is 14.5, y is 6. So I'm going to take my first equation, 4x minus 5y equals 28, and I'm going to substitute 14.5 for x, 6 for y. 4 times 14.5 gives me 58. 5 times 6 gives me 30. 58 minus 30 is 28. This is a true statement, so this works. But now let's check the second one. Second equation, we had 2x plus 3y equals 47. We replaced the x with 14.5, the y with 6. 2 times 14.5 is 29. 3 times 6 is 18. 29 plus 18 is in fact 47. This is true. Guess what? This is our solution. Okay, the solution to the system is 14.5 and 6. We got it right. We're happy. Good job, guys. Okay. Now, let's look at another example. Same idea, slightly different. We have to do one extra step here. We have two equations, 6x minus 3y equals negative 3, and 5y equals negative 4x minus 9. This is our system. Remember what I said about aligning all of your terms that are the same. Here I have an x term. The minus or plus don't matter right now. A y term, an equal sign, this is important, and then a numerical term without a variable. So it goes x, y equals number. Does this go x, y equals number? No. So the first thing I'm going to do before I choose what variable I want to eliminate is I'm going to make sure that everything's aligned the same way. Okay? So I'm going to do that. I'm going to change up the second equation. I'm going to leave the first equation alone. I'm going to take my second equation because it's really easy to change. I'm going to move my x term over. So if the original was 5y equals negative 4x minus 9, I'm going to add 4x to both sides. And I'm going to get 4x plus 5y equals negative 9. Okay, now x term, y term equals number, x term, y term equals number. They're aligned. Okay, now I can move on to my step where I choose what variable I want to eliminate. Okay, so now that we've got everything together, aligned up, aligned, whatever, now I can actually use elimination to solve. So the first thing I have to do is figure out what variable I want to eliminate. Well, if I'm looking at this, I've got a 6x and a 4x. I have a negative 3y and a positive 5y. Remember, you can only eliminate variables. You cannot eliminate the numbers. That's not going to help you because if you eliminate the numbers, you still have an x and a y in your equation. Okay? If you have two variables, you can't just solve a linear equation. You need to use a system, get rid of one of them, and then solve for the one. So you can use either x or y. It does not matter. I personally am going to choose to eliminate y. Why am I going to eliminate y? Because they're already opposites. I have a negative here and a positive here. I just have to manipulate the equations so that I can change this 3y and this 5y so that I get a common number, okay, that are opposites of each other. So what am I going to do? Common multiple of 3 and 5 is, good, 15. So I'm going to manipulate the first equation by distributing a 5 throughout, and I'm going to manipulate the second equation by distributing a 3 throughout. So multiply both sides of the first equation by 5 and both sides of the second equation by 3. So the first equation, I'm going to distribute the 5. I wrote it out a little bit differently as earlier. I distribute it to the left side and then I distribute it to the right side instead of making parentheses around the whole thing. Either way is fine. Just depends on your preference. So when I distribute the 5 times 6x gives me 30x. 5 times negative 3y gives me negative 15y. And 5 times negative 3 gives me negative 15. Now the second equation, distribute a 3. 3 times 4x gives me 12x. 3 times 5y gives me 15y. 3 times negative 9 gives me negative 27. I have a positive 15 and a negative 15. So when I add these two together, I'm going to eliminate my y's. So let's do that on the next slide. I'm going to combine the two. Remember, we have to keep them aligned. Okay, we stack them up and align everything. This is why we did this in the beginning, so that we didn't have to do it later. 30x plus 12x gives me 42x. Negative 15, positive 15 with the y's cancel out. And then negative 15 plus negative 27 gives me negative 42. Here's a toughie. How do I solve this? Good, divide by 42. Negative 42 divided by 42 gives me negative 1. So x equals negative 1. So again, we're going to solve for y now that we know what x is. We're going to substitute. I had 6x minus 3y equals negative 3. Plug in negative 1 for x. 6 times negative 1 gives me negative 6. Minus 3y equals negative 3. Now I'm going to add 6 to both sides, which gives me 3y equals, or negative 3y equals 3. So y equals negative 1 when I divide by negative 3. Okay? So I get y equals negative 1. So my point should be negative 1, negative 1. We can check that. Okay, we can check that our point is negative 1, negative 1 by plugging it into both equations and making sure that it works. 6x minus 3y equals negative 3. 6 times negative 1 minus 3 times negative 1. 6 times negative 1 is negative 6. Minus 3 times negative 1, which is negative 3. So I get negative 6 minus negative 3. Negative 6 minus negative 3 is negative 3. Remember, subtracting a negative is the same thing as adding a positive. So this is a true statement. Second equation, 4x plus 5y equals negative 9. 4 times negative 1 is negative 4. 5 times negative 1 is negative 5. Negative 4 plus negative 5 gives me negative 9. This is true as well. So my solution ends up actually being negative 1, negative 1. Here's a fun one. Now, solving systems of linear equations by the addition or elimination method. Here are our steps. Okay, step 1. You're going to rewrite each equation in standard form, eliminating fraction coefficients, meaning you're going to align all of your like terms. You don't have to eliminate fractions. I just feel like most of you would prefer to do so. That's fine. But you should always align your like terms. That's what your first step is. Make sure that everything's in the same order. In the last exercise, or the last example, we changed everything so it was x, y equals number. Okay? Does it always have to be in that order? Not necessarily, but you have to make sure that everything's aligned the same way. Second step, choose the variable you want to eliminate. This is up to you. You can eliminate either x or y. There's no right or wrong answer. The only thing that's going to matter is your computations, okay? Your arithmetic. That's going to be right or wrong. If you multiply incorrectly, or you add incorrectly, or you divide incorrectly, then it's going to make a difference. Once you do that, you're going to multiply one or both of the equations by a number so that the coefficients of a chosen variable are opposites. Okay, in the last example, we multiplied by, I believe we multiplied by 5 in the first, we multiplied by 3 in the second. Okay, so we manipulated both equations by multiplying. Then you're going to add your equations together. Okay, we had a positive 15y and a negative 15y. We added the two equations so that the y's would cancel out, and we were just left with an x term equals a number. Okay. Then you're going to find the value of one variable by solving the resulting equation from step 4. Okay, that's what we did. When we figured out that x was negative 1, we found the value of that one variable after we eliminated the y's. 6. Find the value of the second variable by substituting the value in step 5 into either original equation. So we've been doing that since substitution method. You solve for x first, you plug in that x, then you solve for y. You solve for y first, you plug in your y value into either equation, you solve for x. Okay? Same thing that you've been doing. And then you need to check, just like we did in the last two examples. You check to see that if you plug in that point that you got for x and y, that it works for both equations. I will tell you that sometimes it works for one equation, doesn't work for the other, because you messed up something in your computations. That's happened to me a million times. Okay? I've been working on these problems for a while. I do mess up. It happens to everyone. That's why we need to check our work. Okay? Always. Uh-oh. We have fractions. So we have to solve the following system of equations using the elimination method. Well, you could do this with fractions. In fact, you already have two opposite terms where you can get rid of your y's. If this is still freaking you out because there's fractions, get rid of them. Get rid of them. First, multiply both sides of the equations by a number that will clear the fractions out of the equations. Okay? You can get rid of your fractions. However, remember what our goal is. Our goal is to eliminate one of my variables. Well, since these are already opposites of each other, we should multiply both terms by the same number. Okay? So that this y and this y, which are already opposites of each other, can just cancel out. Well, let's look at the first equation. I have a 3, a 4, and a 2 as my denominators. I have to come up with the common denominator so that I can get rid of these fractions. What's a common multiple of 3, 4, and 2? Good, it's 12, right? It's 12. So I can multiply this all by 12 and it's going to get rid of my fractions. Well, guess what? If I multiply this all by 12, it's also going to get rid of my fractions. The only difference is, instead of using a smaller common multiple, which you should be able to see, I have a 2 and a 4. Common multiple would be 4. The reason why I'm choosing to do 12 on both is so that when I multiply this by 12, which is 1/4, and negative 1/4 by 12, I'm going to get the same number, and I don't have to do more steps to get these y's to be the same, well, opposites technically, and cancel them out. Okay? So the next step, I'm going to multiply the first equation by 12. I have 2/3 x plus 1/4 y equals negative 3/2. I distribute a 12 on both sides. 12 divided by 3 is 4. 4 times 2 is 8. I get 8x. 1/4 of 12 is 3. I get 3y equals 12 divided by 2 is 6. 6 times negative 3 is negative 18. Okay, so my new equation now becomes 8x plus 3y equals negative 18. And these two equations are the same. This first one and this last one mean exactly the same thing. Let's look at the second equation. Remember, first equation is 8x plus 3y equals negative 18 now, after we manipulated that equation. Second equation, which was 1/2 x minus 1/4 y equals negative 2, we decided that we were going to multiply all this by 12 again. So we're going to do that. Half of 12 is 6, so we get 6x. 1/4 of 12 is 3, so we get 3y, but it's minus, so we get a minus 3y. And then 12 times negative 2 is negative 24. Okay, so we distributed the 12. We ended up getting 6x minus 3y equals negative 24. These two equations are exactly the same. They mean the same thing. We just manipulated it. Now, we have a positive 3y and a negative 3y, so we can add these two together, eliminate the y's, and solve for x. So let's do that. Make sure everything's aligned. I have 8x plus 3y equals negative 18 plus 6x minus 3y equals negative 24. 8x plus 6y gives me 14x. My y's cancel out because positive 3y and negative 3y just gives me 0y, which is 0. And then negative 18 plus negative 24 gives me negative 42. So now I have 14x equals negative 42. So simple to solve. Divide both sides by 14, and I get x equals negative 3. Okay, so right now, I have x equals negative 3. I have to solve for y. So let's do that. I plug in to my first equation, 8x plus 3y equals negative 18, and I'm using this instead of the fractions. It's fine. This works perfectly. 8 times negative 3 is negative 24. Plus 3y equals negative 18. I add 24 to both sides. I get 3y equals 6. 6 divided by 3 gives me 2. So y equals 2. My point is negative 3, comma 2. Still have to check it though. Okay, maybe I messed up. So I'm going to look at these. I use the fractions just because I feel like some of you want to use the original equation. That's fine. If you don't want to use the original equation, use the ones you manipulated. The only problem with the ones that you manipulated would be if you manipulated them incorrectly. Okay? Let's say I changed the first one correctly, but I changed the second one incorrectly. Then checking your answer might not work out properly. So try to use the original problem. Okay? Just try that. I know it's scary. There's fractions. Ooh, who cares? You guys have dealt with fractions. You guys have been amazing with fractions, okay? So just keep it up. 2/3 times negative 3. The 3's cancel out. I get negative 2. 1/4 of 2. 2 times 1/4 is 1/2 because I get 2 over 4, which is 1/2. Negative 2 plus 1/2 gives me negative 1.5, which is the same thing as negative 3/2. It's a true statement. Same thing here. Negative 1/2, sorry, positive 1/2 times negative 3 gives me negative 3/2. Minus 1/4 times 2, which gives me negative 1/2. Negative 3 halves minus 1 half. Remember, that's negative 1.5 minus 1 half gives me negative 2. That's a true statement. Okay, so this works out. So that means that we were right. Our point is indeed negative 3, comma 2. Okay, that's it. It's negative 3, comma 2. And we just checked it. We proved it. We're right. We're happy. We got 100%. We're awesome. Special cases. We've talked about this a million times. You can either have one solution, which gives you a point like we got in all those examples that we just did. If we end up eliminating all of our variables, let's say that when we added them, our x's and our y's canceled out. Who cares? We know what that means. Just depends on whether we get a true statement or an untrue statement. Okay, this is a false statement. When it's a true statement and all of our variables cancel out, we have infinite solutions. Okay, infinite solutions. When I have a false statement and all my variables cancel out, like 0 equals 6, we have no solutions. Okay, just a brief review. Still applies. It doesn't matter what method you're doing. There's systems of equations. Okay, when we deal with linear equations, those are our 3 options. One solution, which is always a point. Infinite solutions, which is when your variables cancel out and you get a true statement, and no solution, when your variables cancel out and you're left with a false statement. Okay, I hope that was helpful. Thank you guys. I have a little bit of work for you to do. We're going to be doing this the rest of the week. And then we have a small little activity to do on Friday. Okay? Thank you.